All right, recording has started. Arc length and area of a sector. So we're going to be using two formulas, and we're going to put them right on your unit circle. First one I'm going to put in this bottom left corner. I'm going to write arc length.
Excuse the interruption, but if you were so kind to grab Macy J. John Scar's stuff out of Mr. Vanderplas's room, please bring it to the office at this time because it's unable to be located. If you have Macy John Scar's stuff for classes, please bring it to the office at this time. Thank you.
That's just supposed to be a colon there, like this is what it is. And the formula is S equals R times theta.
So what's the thing after one?
So it says arc length, that's supposed to be a colon. I'll use some whiteout. My pen just started running. S equals R times theta. And then over here, everybody write it down? And then over here, on top of these boxes, we're going to write area of a sector is 1/2 times r squared theta. Do you guys remember from geometry that if you had an arc across the circle, that was equal to half of the angle across the circle? Do you remember this at all? So like, I'm using a Post-it here because I don't want you to draw this in your notes. Remember pictures like this? Yeah. And where it said stuff like, ooh, this angle is 50, which means that this arc is also 50. That's 50 degrees of the arc. And they remember this one was half over here. Does this look familiar at all? Okay, Kyle says yeah. Everybody else is staring at me in absolute silence. Are you yesing to yes, we're staring, or yes, you remember it? Both? Okay. All right. So what we're going to do is we're going to kind of talk about where these formulas come from. I'm going to write them again on here. Arc length is S equals R times theta. And the area of a sector is 1/2 r squared theta. And that equals area. Okay. So the arc length thing makes sense because it's a relationship between the sides. For example, if you had let's suppose we had a circle that had a radius of 1. Okay, if it had an exact radius of 1, then this distance here would be pi. Remember that? Half a circle's pi. We did this last week. Half a circle's pi, the whole circle's 2 pi. Okay? But that's only if the radius is 1. And remember, this is a unit circle, so the radius is 1 on this. But we do have to change it based on what the radius is. So you take the angle, like in this one it says pi, and then you multiply it by the radius. In this case it would be 1, so this length would be pi. But if this was a radius of 2, then it would be 2 times pi, etc. So this angle needs to be in radians. So does this one. Okay, so let's try this. Example 1. Let's say that you've got a circle. And it's got an angle in here that is 3 pi over 8. That's in radians. And the radius of this circle is 18.2 centimeters. And you were trying to figure out this length. So you'd use the formula arc length right here, and we take the radius times the angle in radians right here. So in your calculator, you're going to type in 18.2 times parentheses 3 pi over 8 parentheses.
Do we have to change it to radians or not?
This is in radians.
Do we have to change our calculator to radians and degrees or no?
No. You don't.
Okay.
Because that would be totally important if we were doing like sine or cosine or tangent, but this is just a number, 3 pi over 8.
Okay. Where's the pi button? That's
The pi button is, it's the caret button. If you do this right, you should get 21.44 centimeters.
what?
21.44 centimeters.
Yeah.
Okay. Now, what if instead, what if we had the same example as this one? But this time instead, and we've still got what? This radius is still 18.2 centimeters, but now I'm going to say it's 144 degrees in here. And we're going to try to find this. Ideas? Yep. Right. Okay, does anybody have an idea of how we could change degrees to radians?
Look at the
We just really need some sort of proportion, right? Like where you'd be like, oh, 1 mile equals so many kilometers, or, you know, a kilometer equals so many miles, right? We need a conversion. But we do know what a whole circle equals, so this